Right. So E1CB reactions yesterday we discussed, right? No. When poor living group is present, so when strong base we are using, so Hoffman elimination takes place. What exactly Hoffman elimination means? Unstable alkene means nothing but less substituted alkene we will get. So in this case, what we will get here is the major product. This is because here is the hydrogen is taken by this base, so we will get carbene ion. So we know primary carbene ion is more stable. This carbene ion coming inside, so this is going like that, so we'll get Hoffman product. Like that yesterday I gave you a couple of questions, right? In this case, for example, if you are using the fluorine also, any base, so same product we will get. Major product, Hoffman product is the major product. Write it down. Same product. So, but I gave this type of questions yesterday. Yeah. Tell me, which hydrogen we need to take from? Beta hydrogen we need to take. Beta hydrogen where is only CH3. These are CH3. CH3. Here is no beta carbon, but the beta carbon, this is alpha beta, right? This hydrogen is there. Yeah, this also beta. We can take this also, doesn't matter. Two beta hydrogens. So anything we can take. So the first is going out. This is coming inside. This total as a living group now. So what would be the product? This is byproduct. So last example which I gave you, CH3, CH, OH, CH2, C double bond O, H in basic medium. So remove the water molecule. So which hydrogen we need to remove now? So here is one green hydrogen. One more is yellow hydrogen. Yeah, one is green hydrogen and one is yellow hydrogen. Yeah, tell me which hydrogen we need to remove. So, but green one is second degree, right? Resonance, stabilized, as well as this is withdrawing group, minus I nature. So generally carbene ion withdrawing groups. So carbene ion is stabilized by directly proportional by electron withdrawing groups. Carbene ion is inversely proportional to electron donating groups. Write it down this. So obviously we will remove the green hydrogen here. CH3, CH, OH, CH negative charge, C double bond OH. The next step now. So this coming here, the OH going out, we'll get CH3, CH double bond CH, C double bond OH. We could say alpha beta unsaturated carbonyl compound. Alpha beta unsaturated carbonyl compound. Write it down. Alpha beta unsaturated carbonyl compound. And this is the product of aldol condensation. Write it down. The people who are in second year, that is helpful for them. This product of alpha beta hydroxycarbonyl compound. Beta hydroxycarbonyl compound. Beta hydroxycarbonyl compound. ఇది aldol product అన్నమాట. Aldol product. Right now, so here I will give you 4 compounds. Next, write the products in a different modes. The first compound, so here we can take concentrated H2SO4, H2SO4 on heating. So second 2-chloro, ETOH, ETO minus, ETOH. Third one, O minus K plus bulky group. Alcoholic KOH. So different reagents which I gave you right now. So come and write the products. ఇక్కడ మనకి PQR ఇవి అడుగుతారు. PQR L like that. So like one is stage of product, Hoffman product, stage of product, Hoffman product, right? Transition state, one to alkyl shift, transition state, PQR. Carbocation. So matching type of questions they'll ask. Basically matching type of questions. In this case, now first one, what exactly happens? First OH is going, alkyl shift is takes place. So means 1 to alkyl shift is takes place, right? Well, here. The first one. So those no need actually, okay? Right now. In this case, now first what exactly happens? Water is going out, carbocation is forming. This is the first step, right? Then what exactly happened? Methyl shift is takes place here. Why methyl shift is takes place? Stable carbocation. So then this is the product. Okay. Next one, chlorobenzene. This is exactly stage of product. You get the double bond here. Second one. Third one is Hoffman elimination when bulky group is there. Bulky base. Tertiary butoxide cases. So here Hoffman product. So here sides of product once again. This is the fourth one. Write it down the products 1, 2. This is 1. 2, 3, 4. Write it down. Wittig reaction. So generally aldehydes and ketones. For example, aldehydes and ketones, when treating with R dash, triphenyl phosphine. This is alide. So triphenyl phosphine. So this is Wittig is the name. Is a scientist in 1979. He got the Nobel Prize. So in this case, actually, we have small mechanism, but it's an easy reaction. Simply, the CH2 bond is there, right? CH2 is exchanging. Directly we can write. It's a shortcut method. Whenever this type of aldehydes with alide, so triphenyl phosphate, simply what we can do, exchanges takes place. What exchange? R dash, double bond, CH2, alkene we will get, and triphenyl P double bond O. So first write it down this, PPH3 plus. So this is alide, so nucleophilic addition reaction takes place like this. This is a mechanism. I'm just writing the R dash here. O minus, this is CH2, P, so bonding, plus and minus bonding, PPH3. So then the bond cleavage takes place here, like this. So this bond is going like here, this bonding is coming here, so we'll get R dash, double bond, PH2, plus double bond O, P, PH3. This is a mechanism, Nana. This is a mechanism, write it down. So now write the products further. Simply whenever the questions are given like this, CH3, C double bond O, CH3, so triphenyl phosphine. Come on, write the products. Next one. Come on, what are the products? Simply I told you. What I told? CH2 just replace here and O will substitute over there. Hello. So CH3, C double bond CH2. I'm writing above the here itself directly. Then CH3 plus double bond O. Simple, Nana. So here is also simple. Double bond. One of the easy mechanism is not needed basically. Okay. Here also simple. Double bond O, CH2. Okay. This is about Wittig reaction. Next, Nana. Pyrolysis from esters. Pyrolysis. So the pyrolysis are cracking, which I explained where? Alkenes. Alkenes, when we are absence of oxygen, when we are heating, we'll get low number of alkenes as well as alkenes. We don't know which type of products are forming, but it should be lesser alkenes as well as alkanes. From esters, no? For example, this is ester, right? So the here is try to understand beta hydrogenase must be present. This is alpha, here is beta. right? Because in this case, Hoffman product type of alkenes are forming, means unstable alkenes. Particularly, first I'll tell the product. Like this product is forming plus CH3, T double bond O, OH, carboxylic acid is forming. Means what exactly happens here? Cyclic 6-membered ring form out. 1, 2, 3, 4, 5, 6-membered ring cyclic transition state is forming. 6-membered transition state, like the 6-member transition state is forming. So that's the reason Hoffman alkenes are forming. So here is a hydrogen is going out, so Hoffman alkene. For example, we'll take one more. So this is useful for advanced exams, but not for mains. This is ester. So how we will get the product on heating? Here is the hydrogen, beta hydrogen. Hoffman elimination takes place. Write it down. Hoffman elimination. Hoffman elimination means what? So because this hydrogen only, so cyclic, right? 6-membered cyclic transition state is forming. 6-membered cyclic transition state is highly stable. So directly I can write the product. Here is the alkene and T double bond OH is the byproduct. So next put the heading after writing this, physical properties. Physical properties. Physical properties of alkenes. Physical properties T1 to C4 are gases. Yeah, C1 to C4 gases. Are Gautam ani Nalgonda nunchi abbayi last time 99.75 percentile వచ్చింది నల్గొండ నుంచే. ఇప్పుడు ఐఐటీలో 3000 ర్యాంక్ వచ్చింది. ఐఐటి పాట్నాలో కంప్యూటర్ సైన్స్ జాయిన్ అయ్యాడు. ఐఐటీలో చాలా ఐఐటీస్లో వచ్చింది. నమస్తే. C5 to C16 are liquids. Liquids. Above 1 are C17 onwards solids. So what are these? Alkenes, right? Alkenes are more reactive than alkenes. Alkanes. Alkenes are more reactive than alkanes. Alkanes are somewhat inert nature because they are saturated hydrocarbon. Alkenes are more reactive. So generally melting and boiling points increases with the increasing the molecular weight. So next, I told you alkenes boiling point, melting points. In isomerism also I explained. Cis and trans cases, for example, which one is more boiling point, or cis and trans, which if they are having the same molecular weight? Recently I explained, right? A double bond C, for example, CH3, CH3, H. This trans. So dipole moment is not equals to 0. It is dipole moment equals to 0. I told you dipole moment is directly proportional to polarity as well as boiling point, right? So dipole moment, which one is greater than is greater than trans. Next, boiling point, polarity also write it down. Polarity is greater than trans. Boiling point is greater than trans. Is greater than trans. Melting points only, melting trans greater than is because of symmetrical and close packing structure. Symmetrical and close packing structure. Because symmetrical and close packing structure. Close packing structure. Write it down. Alkenes are soluble in non-polar solvents. Write it down. Alkenes are soluble in non-polar solvents. Alkenes are soluble in non-polar solvents. Non-polar solvents. Actually, alkanes are non-polar, but alkenes and alkynes are slightly polar. Write it down. Alkanes are non-polar. Alkanes are non-polar, but alkenes and alkynes are slightly polar. Slightly polar because of electronegativity difference. In case of alkenes, the carbon is sp2 carbon, right? And in case of alkynes, sp carbon. So percentage of s character increases, electronegativity increases, slightly polar. So that's the reason the solubilities in non-polar solvent, or the order is, the solubilities in non-polar solvents in order is, alkanes are more soluble than alkenes, then alkynes in non-polar solvents. In non-polar solvents, because I told you like dissolves like polar compounds are soluble in polar solvents and non-polar compounds are soluble in non-polar solvents. Sometimes they may ask the question is like this. For example, non-polar solvent benzene or something is given which is more soluble. Alkane, alkene and alkane is given. So how should we know? Means so based on polarity we have to say. And these are lighter than the water. They are floating on the water. Floating on the water. Next, chemical properties. Chemical properties of alkenes. Chemical properties. I told you alkenes undergoes which type of reactions? Alkenes undergoes which type of reaction? Electrophilic addition reaction. For example, CH3, CH2 double bond CH2. H plus can come and attack. Okay, CH2 plus CH2H. This is happens, Nana. This is okay. Electrophile is adding, right? That's why we could say the electrophilic addition. For example, OH minus, Andana. Is it possible? It is not possible. Why? Yeah, alkene, above and below alkene, electron density is there, negative charge, and OH minus also negative charge due to electron repulsions. So nucleophilic addition is means After first electrophile is attacking, then positive charge is generating. So now the OH minus can attack here. The OH minus can attack over here. So this, of course, nucleophile is adding. Nucleophile is adding. But when who is initiating, who are initiating, right, the name goes to them. ఎవరైతే రియాక్షన్ ఇనిషియేట్ చేస్తున్నారో వాళ్ళకి పోతుంది ఆ పేరు. ఎలక్ట్రోఫైల్ న్యూక్లియోఫైల్ రెండు ఉన్నాయి కదా. ఎలక్ట్రోఫైల్ వచ్చి స్టార్ట్ చేస్తుంది, బట్ నాట్ న్యూక్లియోఫైల్. ఎలక్ట్రోఫైల్ స్టార్ట్ చేస్తే ఎలక్ట్రోఫిలిక్ అడిషన్ రియాక్షన్, రైట్? Along with electrophilic addition, alkenes undergoes which type of reactions? Alkenes only, right? Alkane undergoes free radical substitution reactions. So alkenes undergoes electrophilic addition, right, as well as free radical addition reaction. Free radical addition reaction. Free radical addition reaction, when it is takes place, when peroxide, here is, when the peroxide is present, write it down. When peroxide is present, then free radical addition. Absence of peroxide, electrophilic addition. Absence of peroxide, electrophilic addition. Clear? Electrophilic addition reaction. CH2 double bond CH2 plus HBr, for example, HBr, H2O, whatever it may be. So the symmetrical alkene. Alkenes are two types only. Okay. H, CH2, Br. Addition reaction. Double bond will become single bond. The mechanism. So first HBr undergoes H plus plus Br minus. H minus Br plus is possible? No. Why? Bromine is more electronegative. When we are breaking the bond between H and Br, Br is more electronegative. It takes the right electrons from the hydrogen. H plus and Br minus. H plus is electrophile. What is electrophile? This is nucleophile. Electrophile means electron deficient species. The people who don't know, for them I am telling. CH2 double bond CH2. Alkenes are two types, right? Symmetrical and symmetrical. Symmetrical ante madhyalo cut cheste two, if the two equal halves, that is symmetrical. So if you are cutting here, symmetrical, no issues. Now H plus is coming and attacking here. H plus I am adding here particularly. H plus is having how many electrons? 0 electrons. Mari, for the formation of bond we need 2 electrons, right? Where this electron, where the electrons are coming from? This double bond undergoes heterolytic cleavage. Heterolytic cleavage. For example, I am just writing with this green color. This is coming like this, Nana. CH2 positive charge here. So that green color वाला नीचे आ जाएगा, यहाँ से H. अर्थమైందా? This bond is total. Bond break అయిపోయి వచ్చేసింది. So then we got the carbocation. Then Br minus is coming and attacking the positive charge. So now no repulsions. So this is a mechanism. This is slow step, no? So bond is breaking there. Here is H plus. Electrophile is initiating the reaction. That's why this reaction, total reaction, we call as electrophilic addition reaction. So write it down. Electrophile is initiating. Electrophile is initiating. So that's so. You could say electrophilic addition reaction. If nucleophile is initiating, nucleophilic addition reaction. These are the write the products. Okay, I'll explain this because this is unsymmetrical one. Unsymmetrical one. Once again, the mechanism, Nana. HBr undergoes H plus plus Br minus. So CH3 CH double bond CH2 Obviously first H plus is coming in attacking. The H plus attacking here, it has two options now. It can attack over here, it can attack over here. Two options are there in front of us. Two options are there, right? So where it is attacked, yellow position or green position? Akshita? Yellow. If it is yellow position, we'll get 2 degree carbocation. If it is green position, 1 degree carbocation. Carbocation stability we know, right? 3 degree, then 2 degree, then 1 degree, right? PH3, PH plus, PH2H. Then Br minus is coming in attacking. PH3, PH, Br, PH3. This is a major product. If it is at green position, that is minor product. Major product. For example, if you are writing like this, CH3, PHH, this is less stable, no? Br minus, PH3, PH2, PH2, Br. This is minor product. There is major, this is minor. Write it down. So carbocation, whenever the carbocation, I told you once again, rearrangement, natural tendency of rearrangements are possible. Natural tendency of rearrangements. Now these questions do as a homework. Then afterwards, these questions write along with water. H2O in presence of H plus. So next case, in place of HBr, in place of HBr, H2O in presence of H plus and పెట్టండి. That is the Br place లో OH వస్తుంది. OH వస్తుంది. Same mechanism, everything is same. Hello, same mechanism and everything same. HBr place లో OH, H2O in presence of H plus. So the product is HBr place లో OH వస్తుంది. Next question, HBr in presence of peroxide పెట్టండి. If you know already I explained in free radical addition reaction. Hello, third type of questions ra. Hello, HBr in presence of peroxide nana. Peroxide. Once again these 9 questions, write it down. Once again these 9 questions, HBr with peroxide, same questions. Peroxide. So for the clue and same questions which I gave in free radical addition reaction in the reaction mechanism. So if you don't know, just go back the videos. There you can watch free radical reaction mechanism. There I explain free radical addition reaction mechanisms. So then afterwards, tomorrow I'll explain ozonolysis, reaction with KMnO4, reaction with OSO4, hydroboration, oxymercuration, demercuration, polymerization reactions, so the alkenes. So easy one only. But main thing is this 9 plus 9 plus 9. 10, 10, 10, 30 reactions. These 30 reactions, From the reaction mechanism, we can write directly. Okay, now? Right. So if you didn't get these questions, go back to the reaction mechanism. There I explained everything. So you can copy from over there. So any doubts, let me know in the next class.